Hi, this is Vidyasagar, welcoming everyone to this lecture where we will be discussing on the topic the size of the universe and the vastness of space and exploring the size of the universe. And the fact that this topic enthusiasms everyone is about its incomprehensiveness, in which we will try to make it more comprehensible by understanding this lecture. Yeah. So let's start the discussion from our very own backyard by taking our very own moon and earth and know about the relative sizes and distances and build our way out to the whole universe that we know. Okay. So let's start by picking up a watermelon and an apple, just for comparison. And like the earth here corresponds to the watermelon and the apple corresponds to the moon. Basically that's a pretty good relative comparison of Moon to the Earth in terms of sizes. And matter of fact, if Earth was a hollow and if we needed to fill it with moons, that would require us around 50 moons to fill the whole hollow Earth. And weight-wise, as you know, Earth is much more denser than Moon due to its metallic core. It takes around 80 moons to balance out the whole Earth on a weighing scale. And coming to the distance between them goes beyond 28 Earth diameters. So you can just imagine keeping 28 Earths side by side to reach the complete moon. Uh, And yeah, the fact is that you can just imagine that mankind has never made it past the moon. Of course, we have sent satellites and vehicles beyond it, but it has been our little universe here where we have made our physical appearance. And after the moon, let's push our boundaries and go beyond and explore all the planets. Here, as we all know, that star that we all call as sun, and there are four terrestrial planets with solid surfaces, like where we can just roam around. And next is there is an asteroid belt with a lot of dust, debris, and rocks. And next we have four gas giants. And beyond that, we have Pluto, which we considered earlier as a planet, but now it lies in a region called as Kuiper Belt region. Yeah, I guess. A region that is filled with icy bodies mostly, with like most of debris and water ice, whatnot. And there are other bodies such as Eris and Sedna in that area. So yeah, coming to the feel of the sizes, let's start with Sun, which is the center of the solar system. If Sun wasn't hollow, then of course, like if you want to fill up with Earth, then it would take 1 million Earths to fill up the whole Sun. Wow, that's a staggering number. And when we move to the gas giants, like if we could fit Jupiter's inside the Sun, it would take around 1,000 Jupiters. So you can just imagine that you need 1,000 Earths, sorry, to fit the whole Jupiter in. And yeah, of course, by these numbers, you can just assume that Jupiter is an enormous gas giant. And matter of fact that Sun itself holds 99.5% of the total mass of the whole solar system. And to talk in terms of distance now currently, the distance between Earth and Sun is around 149 million kilometers on an average. And if I'm not sure, this distance is called 1 astronomical units. In that units, if we could measure all the planets, then Mercury would be around zero point 0.4 AUs. That is 40% from the sun from where the Earth is. So yeah, the Venus would be around zero point 0.7, Mars or 1.5, asteroid belt would come around 2.3 AUs, and the gas giants, that is Jupiter, would be 5, Saturn 11, Uranus 20, and Neptune would be 20, yeah, 30, I guess, yeah. And Pluto would be 40 astronomical units. You can just imagine, like, if you could travel from Sun to the Earth in 1 year, then it would take 40 years to reach the Pluto. So, like, it's a very far out there, cold and lonely out there. Yeah. Now let's switch some gears and talk about distances in terms of light travel time. Light is incredibly fast, moving at speed of 186,000 miles per second. That is around 300,000 kilometers per second. That's really fast, I should say. To give you an idea of this speed, you can just imagine if you could travel at the speed of light, you could circle Earth 7.5 times in just 1 second. However, light, as fast as it is, takes about 8 minutes to travel from Sun to Earth and approximately 4 light hours to reach Neptune. That would be like if you send a signal to the Neptune, you would get it with an 8 hours delay to go and get back. And yeah, now when we look at the distance to Pluto, it's around a 5.5-hour journey for light to make it there. And beyond Pluto, the distances become even more mind-boggling. For instance, the next icy body, Eris, is around 68 AUs away from the Sun. That's roughly 68 times the Earth distance from the Sun, I guess. Yeah. But let's consider the vastness of the interstellar space, that the blank space that we're talking about. The next nearest star, Alpha Centauri, is around 4.5 light years away from our solar system. To put this into perspective, light travels that distance for 4.5 years. If you imagine the sun as a ping pong ball and Earth as a tiny grain of sand placed around 15 feet, just 15 feet away, the distance to the Alpha Centauri would be approximately 800 miles. That would be like 1,300 kilometers away. Huh? That's really vast space, like really blank. And yeah, this vast expanse of emptiness between stars gives us a glimpse of enormity of this whole universe. And this is just to the next nearest star that we're talking about. So next we will delve even deeper to explore the size of our galaxy as we have finished the solar system and begin to comprehend the immense scale of the cosmos relative to these sizes. Milky Way galaxy. So far, we have explored our own planet, our solar system, and now we are diving into the grand scale of our galaxy, the Milky Way. You might be wondering why we call it Milky Way. Yeah, it's really a thought forming. Well, in ancient times, people gazed up at the night sky and noticed a band of light stretching across it. To them, it looked somewhat like Milky at haze, hence the name Milky Way. Our Milky Way galaxy isn't just a random cluster of stars, it's a colossal collection of stars, and we reside within it. So just picture our galaxy as a flat, thin, circular disk like an old vinyl record. Huh? At the center, it bulges out like a spherical hub, and it's surrounded by a vast disk of stars. When we look toward the Milky Way's disk, we see stars as far as I can perceive in all directions, creating the characteristic glowing band across our night sky. Okay, now let's grasp the sheer size of our galaxy. It spans approximately 100,000 light years from one end to the other end, possibly even a bit more. This means that if you are at one end of the Milky Way and if you just flash a flashlight toward the other end, that beam of light would need a staggering 100,000 years to traverse from one side of the galaxy to the other, provided it doesn't encounter any obstacles along the way, like dust clouds or stars. To put this in perspective, consider that light travels at speed of 186,000 miles per second, which is speed of light. It takes little over a second for light to journey from Earth to Moon, and just over 8 minutes to reach the Sun. However, to cross the Milky Way, it requires 100,000 years. Imagine just the immensity of it. Now you might be wondering, what's the scale of this immense galaxy with respect to our solar system? Okay, if we place two stars like our Sun, each representing the size of our Sun in relation to each other, we'll have to separate them by hundreds of miles or kilometers at the scale we are discussing. Imagine how gigantic the Milky Way galaxy is. In our galaxy, we are not alone. There are around 250 billion stars, similar to as our sun, arranged in this vast disk-like structure. It's a mind-boggling number, and yet it only scratches the surface of the cosmic tapestry, which I would like to call. Yeah. Our sun, which is part of this majestic collection, is situated approximately 27,000 light years away from the galactic center. And while the galaxy rotates slowly, it takes about 250 million years for our Sun to complete one rotation around the Milky Way. But what lies beyond our Milky Way? Once you venture outside the galaxy, there's mostly empty space with very few stars scattered about. However, neighboring our Milky Way are some dwarf galaxies, like the large and small mm, Magellanic Clouds. And there's another substantial galaxy, the Andromeda Galaxy, located around 2.2 million light years away from us. To comprehend the magnitude of this distance, consider the light from Andromeda Galaxy takes an astonishing 2.2 million years to reach us. So, moving at the speed of light, you know, the value, this galactic void with virtually nothing to obstruct it, the passage of light underscores the vastness of our universe. As we contemplate these incredible distances, we realize that our understanding of the universe's size and the number of galaxies within it is a subject of great fascination. Next, we will begin to explore the grand scale of the entire universe, filled with countless galaxies and even more remarkable mysteries.